This is problem 1.85 in the 11th edition of Chang. The problem reads, the thin outer layer of Earth, called the crust, contains only 0.50% of the Earth's total mass, and yet is the source of almost all elements. Silicon is the second most abundant element in the Earth's crust at 27.2%. Calculate the mass of silicon in kilograms in the Earth's crust. And it's given that the mass of the Earth is 5.9 times 10 to the 21st tons. 1 ton is equal to 2,000 pounds, and 1 pound is equal to 1 pound is equal to 453.6 grams, or 1 kilogram is equal to 2.2 pounds. So the first thing we want to do is we want to calculate the mass of the Earth's crust. We know that the mass of the Earth is 5.9 times 10 to the 21st tons, and we know that the crust makes up 0.5% of that mass, so that's the 0.0050. Okay, multiplying those two, we get 2.95 times 10 to the 19th tons, which is just the mass of the crust. Now, to specifically determine the mass of the silicon in the crust, we know that silicon makes up 27.2% of that mass, which is what this number is, multiplied by the mass of the crust, and we then want to include some conversion factors to get our quantity of silicon in terms of kilograms. We would multiply that by, we have 2,000 pounds per ton, tons will cancel, and then we would multiply this by the relationship between kilograms and pounds. Pounds would cancel, leaving us with the kilogram quantity. In doing so, the final answer, which is in kilograms, is 7.3 times 10 to the 21st kilograms of silicon. We have included the appropriate units, and we have included the appropriate number of significant figures, which is 2.